Hi friends, today we will teach you the number system. In our digital logic or any other subject related to digital electronics, this topic is very important and the basic. Let's start the topic, the number system. Welcome to our channel, Key of Education System. Today's topic, number system. The very common number systems are decimal, binary, octal and hexadecimal. Decimal number system 0 to 9. We all know this number system. So the total number 0 to 9, the 10. How many number in a number system is there? That is called the base or radix. So the base or radix of the decimal number system is 10. The symbols are 0 to 9. It is used by the human and also used in computer. No, for the computer use we have to introduce another number system, that is binary. There 0 and no 1. 2 number is there. So the base should be 2 number. So base is 2. Now others number system, it is not used by the human but used by computer. For others, 2 number systems are there. Octal who have 7, 0 to 7, 8 numbers, and hexadecimal who have 0 to 15, 16 number. Now let's continuing how to these numbers work. See here I am giving you some chart of number which will be converted. See here 0 all are same, 1 should be 1 all are same. When 2 is coming, then in binary it will be represented by 10. In octal and hexadecimal are same way. Similarly, from 8 to 15 you can able to see here up to 9 it is okay for hexadecimal. Now after that it will transfer to the alphabetical order A to F. See here. Now another thing I have to tell you here, that for octal 0 to 7 are there. After that whenever this 8 is coming, that will comes to the both order. Similar way, when it is 8 then it will comes as 10, then 11, 12, 13 in this order up to 15 you can able to see here. You can ask how this is conversion is done. Today we will do that also. So for that purpose I am just before that showing you how it is work. So let's start the conversion between this all numbers. See here, decimal to octal, decimal to binary, decimal to hexadecimal. In vice versa order also it is possible. So from any number we can able to convert to any other number. So let's start this conversion. So before that what we read? All the number system, that means very common 4 number system, decimal, binary, octal and hexadecimal. 3 number system, their bases and radix and their total numbers. This is known. Now the chart was given, but you can say how can we remember this? Hello ma'am, I don't have to remember. Don't worry, you don't have to remember. Today we will learn in such a way there you can able to convert very easily. So let's start the discussion. Now for the discussion, at first we want to convert for a fun decimal to decimal. Here one rule you have to follow for any type of conversion. Whenever from decimal to any other number you want to convert, there what you have to do? Yes, there you have to do, when you try to convert, it will convert these number systems base. You have to multiply according to this order. The fraction which we will discuss in our later video. In decimal or in case of real number, you have to multiply that number into what base you want to convert their order. See here, just one example. Here, the base is, decimals is 10. So, the 10 to the power. And in ones position, what's the value is there? 5. So, 5 multiplied by 10 to the power 0. From the 0 counting starts. Then 2, it is 10th position, 10 to the power 1. Third position, that is 100th position, which one is there? 1. So, 1 should be multiplied by 10 square. If another value was there, suppose 4, 5, that was in thousandths position, that will be multiplied by 4 or 5 multiplied by 10 to the power 3 according to that. So, which will be weightage, and then it will be converted to the this number. So, this is our decimal to decimal conversion. Now, once more I am showing you where the weight means the value 0, 1, 2, 3, this values is known as weight of that, and the base is 10. Okay. So, which base we have to go from decimal to any other conversion? You have to remember which base we are going. If it is going to binary, then 2 to the power of order. If I am going to octal, 8 to the power. Why 8? Why 2? The base of binary is 2 and octal is 8. Now, let's see binary to decimal conversion. First, binary to decimal conversion. Binary to decimal conversion means whenever any number, binary number means 0, 1, 0, 1 consisting number, it will be converted to decimal. Now, in which base it is here? 2. So, 2 to the power order will be multiplied with that number. Means, suppose 1 is there or 0 is there. So, 2 to the power, the same weightage will be going on from the right side, the ones position, which will be 0, then 1, then 2, then 3, then 4, and this order. So, at first what we have to do? First, 2 to the power order. See here the techniques you can able to see. Here, the techniques is showing multiply each bit by 2 to the power n, where n is the weight of the bit. Now, the weight is the position of the bit starting from 0 on the right. Got it? On the right, most one will be 0. Then according to this order, the weight will be increased by 1, 2, 3, 4. So, we can able to see the, just one example if I able to see, then it will be better. See here, it is given 0, 1, 0, 1, 0, 1, 1. So, the last bit is, rightmost positions is 1. That there, the bit should be 0. So, here this 1 is coming, 1 multiplied by 2 to the power, because binary from we are starting. So, binary 2 base 2 to the power 0. Then next one 2 to the power 1. Next 0 come to the 2 to the power 2 multiplied. Then 1 again 2 to the power 3. 1 0 then again 2 to the power 4. Now last one 2 to the power 5. Now if I multiply the resultant value whatever we will get, then add this whole number and you can able to get 43. That is our decimal number. Got it? So from binary if you are coming, you have to see this all. From the rightmost the weight will be 0 and I have to convert from binaries. That's why the value should be 2 to the power. Now let's see octal to decimal. The similar way here will be, instead of 2 it will be what? Yes, it will be 8. So let's see the technique, then it will be better to understand you. So in technique what you are reading? multiply each bit with the 8 to the power n. There in binary that was 2 to the power n, here it is 8 to the power n. The same way 8 will be the n will be the weight, rightmost position, it will start from 0. The same thing, when from binary to decimal you convert, there was 2, here just instead of 2 it is become 8 because the octal's base or radix is, yes, 8. So that is our octal to hexadecimal conversion. Now let's see one example. If I am able to see this example, then it will be clear very much. Let's see one number. Now one thing remember, you can see the example. There you will get the similar number, but here the maximum number will be 7. 0 to 7. Not 8 and 9 you can able to get there. 0 to 7 will be there. Okay. So let's start that. Say in this example 7 to 4. This is our octal number. Now the rightmost position 4 will be multiplied by 8 to the power 0. Then 2 will be 8 to the power 1 and 7 will be 8 to the power 2. Now multiplying that we can able to get some number. Then sum of this all numbers, that is 4, 16, 4, 4, 8. Sum of them and you will get the decimal number. Got it? Clear? Now if someone asks you, I repeat once again, if someone asks you to convert from hexadecimal to decimal, I think it is easier right now for you, isn't? What you have to do? Yes, here instead of 2, instead of 8, you have to give 16. So the total number, what is you will get in hexadecimal will be multiplied by 16 to the power 0, 1, 2, etc. according to the rightmost position starts with 0. Now here one thing you have to remember, after octal it was 7, but in case of 16 basis hexadecimal, there from 9, from up to 9 it is similar to decimal. Then when it comes to 10, 11, 12, 13, 14, 15, it will becomes alphabetical order A, B, C, D, E, F. Okay. So when we have to multiply, the technique is same. You can able to read. Here instead of that, I have to 16 to the power n, and n is a weighted. Rightmost position it will start from 0. Okay. So up to this level it is clear. Now see this example, A, B, C, 16. A means what? 10. Because 0 to 9 was in numerical order. Then alphabetical order starts from 10. So 10. So at first C. C means what? A is 10, 11 is B, 12. 12 is C. So say 12 into 16 to the power 0. Then B. B means what? 11. 16 to the power 1. A. A means 10. 16 to the power 2. Now you will get this result. 12 into 1, 11 into 16, 10 into 256, and you will get the sum of them and you will able to get the total number. Got it? So any number from the binary, from octal, from hexadecimal, if you want to convert this to the binary number, to the decimal number, then it will be easier for you. Okay? Clear? So, right now after this level, from any number to decimal conversion is covered. Now decimal to any other number, we have to read, and etc. from binary to octal, octal to binary, hexadecimal to binary, binary to hexadecimal. These conversion right now we have to learn. So let's start. The easiest one, decimal to binary conversion. Decimal to binary conversion, I already told you from decimal to decimal conversion time that whenever from decimal any other number you will try to convert, there what you have to do? You have to divide repeatedly with that base where you want to go. So if I got any decimal number here, that decimal number where you want to convert? Binary. Binary's base is 2. Then 2 will be the thing by which we have to divide the number which is in decimal repeatedly until and unless we cannot able to divide it once again. Up to the extreme level we have to divide, and then we have to start our reading. See this example. Before the example, what you have to do? Yes. You have to read the technique. Here divide by 2. Why 2? Binary's base is 2. Track each remainder. If any remainder you can able to find, that you have to track. If you are not find, then make it 0. First reminder's bit will be 0. That means the least significant bit. Okay. Next the second one will be second bits. Next the third one will be the third bits. According to that order we have to go from the bottom up approach. Let's check it, then it will be easier to get. So let's take one example. Here the number is 125. I am taking 125 base is 10. Now 125 will be first divided by 2. So 62 is coming. Remainder is 1. Next again 2. 31. Remainder is 0. Again 2. 15. Remainder is 1. Now 15 once more I have to divide by 2. We will get 7. Remainder 1. Now in 7, if I again divide by 2, we will get 3. Remainder 1. 3. Again divide by 2. So what we will get? 2 twos are 2. 2 ones are 2. And remainder is 1. Now 1. The last mode base state 1. Now what do we have to do? These 1 will be again divided by 2. Now is it divisible? No. So the remainder will comes as 1 and the values will come 0. Quotient value is 0. Now from the bottom up we have to read 1 1 1 1 1. See 5 1 is there, then 1 0 and 1. It will be our binary conversion. So you got from decimal to binary. If I have to go, then what we have to do? By 2 we have to divide until and unless we are getting 0. So this is our decimal to binary conversion. I think it is right now clear. Now if somebody asks you from decimal to octal conversion, right now you can say that easily. Oh, it is nothing to say. Just what we have to do? Yes. Instead of 2, you have to divide it by, tell me along with me. Yes, by 8, because octal's base is 8. Okay, and for hexadecimal it will be 16. Now from octal, if I have to try to convert to the binary, then what do we have to do? Say any octal number I am taking. Here the technique is that convert each octal digit with a 3-digit binary number. How? Whatever, it is 7, then 111. If it is 2, then obviously 10. So a 3 digits number we have to take 0, 10. Say here I am taking 705. Now 5 I want to convert to the binary. You know, 5 will be first divided by 2. Then we will get 2 2s are 4, 1 remainder. Then again divided by 4. So 2 2s are 4. So there we don't need any remainders, that is 0. Then again 2 will come and divided by, so we will get 1 0 1. 3 digit. Okay. 0. No digits is there. So you have to make 3 zeros there. And 7, if you are converting, you will get 1 1 1. Now the answer will be 1 1 1 0 0 0 1 0 1. That will be our octal to binary conversion. Now if somebody asks you, I have to convert from hexadecimal to binary, then what we will say? Hexadecimal means 0 to 15, 16. So 16 means 2 and 16. What's the relation? 2 to the power 4. So here, what you have to do? 4 bits equivalent binary representation of each hexadecimal number should be there. And it will gives you the binary conversion. You cannot able to get? Let's take one example. Make it clear. Say, any example which we have hexadecimal number right now. In hexadecimal number, say this is 10AF. So F means what? 15. 15 means what? The first chart. You can begin to go there. That will gives you 4 1. A, that means 10. You can just convert it. You know right now decimal to binary conversion. So A means what? 10. 10. Convert it. 1 0 1 0. 0 means all 4 are 0. And 1 means 1. But there I have to tell you that should be 4 digit. Why 4 digit? 2 to the power of 4 means 16. That's why 4 digit. Okay. Now 0001 40 tetra 0, then 1010, then 11111. That will be your binary conversion. Got it? I think it is right now clear. From any number, decimal to binary, octal to binary, hexadecimal to binary, you can able to convert. From any number, decimal, you can able to convert. So up to this level, I think it is clear to you. If it is not clear, if you have any doubt, please give us command. If you have any questions also regarding to this conversion related, give it as a order of command. We will try our level best to solve it. Now, the next one part what we have to discuss. So, decimal to any other number system is gone. From others number system to binary conversion is done. Now, what do we have to do? Yes, octal, decimal to octal conversion. I already discussed this. What's that? Instead of 2 division, what I have to do? I have to divide this number, what we will get in decimal number, by 8. Repeatedly we have to divide until and unless we will get 0. That we have to repeatedly we have to divide. So let's see the technique once again. Just for a so divide by 8 and keep track the remainder. The same thing. When decimal to binary convert, we divide by 2. Here we are divided by 8. Why? Because it is octal. So let's take one example. See here 1, 2, 3, 4. Now 1, 2, 3, 4 will be first divided by 8. 1, 5, 4 we will get and remainder 2. Again we will divide 1, 5, 4 by 8. We will get 19 and remainder 2. Again this 19 will be divided by 8. We will get 2 to the 8 to the power 16 and 3 remainder. Now the 2 is coming. 2 if I divide by 8, so we will get anything. We will get anything. We will get 0. This 2 comes as remainder. So what will be from the bottom up approach? 2, 3, 2, 2. This will be our octal conversion. I think this is right now clear. Now decimal to octal done. Now binary to octal. What do we have to do? Any binary converted number, if I take, say the same thing I am taking in that 1, 2, 3, 4. Now divided by 16 at first, so I am getting 17. 2 remainder, then 16 once more we will divide, we will get 4 and remainder 13. 13 means what? Yes, D. Now this 4 will be divided once more by 4 and we will get the remainder 4. So 4D2 will be our hexadecimal converted. Got it? Now binary to octal. How to do this binary to octal? Say one number is there. One number means binary number. Now this binary number, when I try to convert, the technique is that group the bits in 3-3 order. Why 3-3 order? Because 2 to the power 3 means octal 8. Octal's base is 8. Binary's base is 2. It is 2 to the power order. So we can easily convert it. See here, a long number is there. Now I divide it into the 3-3-3 part. From the right side, 1, 1, 1, 1. 1, 1, 1 means 7. 0, 1, 0, 2. 0, 1, 1, 3. Last 1 is there. If I add 2 0 there, that will be also converted to our 1. So 1, 3, 2, 7 will be our octal conversion. From the binary to octal, you can able to learn right now. Now, so there are many conversion, we already did it. It's my hardest request to continue further. Just complete it, then I will request you. Binary to hexadecimal. Hexadecimal's base is 16. 16 means 2 to the power 4. So the grouping should be, instead of 3, it here should be, the grouping will be 4. Yes, 4. So how? Let's take one example to make it very clear. Why 4? It is right now clear. That is 2 to the power, binary's base is 2 and hexadecimal's 4. 2 to the power of 4, that is 16. Now see here, the same number I am taking. Here the grouping is 4-4 order. 1011 means B. Again 1011 means B. 10 means 0010, 4 maps. So 001 means that is our 2. So it will be that. Now octal to hexadecimal. The last one conversion. What's that? It is last. Is there anything left? You can tell. You can give us comment. We can able to solve. Now from octal to hexadecimal, what we have to do? Here the binary. Through the binary use, we will change it. How? See it. 10768. I have to convert it to the, that is, now I'm converting to the binary. How? 3-3 mapping, because from 8 we are going to 2. So 6 become 110, then 111, then 000, then 001. Now this number, after getting this, we have to make it 4-4 order. If I make it 4 order, then it will be converted in such a way 0, 1, 1, 1, that is E. Next 1, 1, 0, 0, that is 3. Next 0, 1, 0, 0, that is 2. Okay, so at first converted to the binary, direct octal to hexadecimal. If you want to go, it is with more complex, no need of complexity increment. So here we will do this. Now hexadecimal to octal, the same thing. Here also in binary immediately we have to follow. So it is 4-4 order we will get, and after that break it into 3-3 order and we will get the answer. take the example, so it will be easier to understand. So friends, after this level, see here, just follow the screen, it will be enough to get it. Now one thing I have to tell you friends, all the conversion whatever possible I did it here. Now one request I already asked you, that solve some problems from internet, any other where you can able to from question paper, solve it. If you face any problem regarding this conversion, then please ask me, because see one thing, it will be a weightage carry for your exam little bit, but it is the base of our digital electronics. It is the base of our Boolean algebra. It is the base of our digital logic. So these base we have to clear. So please don't forget to follow the lecture properly. Don't skip it, and also practice some this type of conversion maths. Okay, here I already gives you one. The solutions is also given. Just you solve, don't use any calculator, just solve it, try to, and obviously you got the answer. If this video is helpful for you, like, share and comments, and don't forget to subscribe our channel and press the bell icon to get the notification of